In today's lesson, we're going to be taking a look at parallel lines. So if you take a look at our definition here of parallel lines, two lines are said to be parallel, provided their slopes are equal. So if you have a situation where you have two parallel lines, let's say we have line 1, line 2, line 1, line 2. This is a linear relationship, so it can be expressed as y equals, let's call this m1x plus b. And this is a linear relationship, so this 2 can be expressed as y equals m2x. I'll call this b1 and then m2x plus b2, just because the y-intercept can be different as well. If these two lines are in fact parallel, so typically parallel lines are denoted as this. If that does happen, and you have two parallel lines, then it must be the case that the slopes of each of these must be equal. So we have to have m1 equaling m2. So if you have two lines that are parallel, their slopes are identically equal. Let's look at some algebraic examples of this. So for example here, if I've got the equation y equals 2x minus 3, or I have the equation y equals 2x plus 4, these two lines are parallel to one another. Another example would be y equals minus 1 half x and y equals minus 1 half x plus 5. These lines are also parallel to one another. And another example of parallel lines, you can have y equals 5 and y equals negative 2. These lines are also parallel to one another. If you take a look here, the slopes of this line here and this line here are both 0. So graphically, what this one will look like is you'll have, look at your Cartesian plane, you're going to have a horizontal line crossing at y equals 5, then another one crossing at y equals negative 2, and these two lines are parallel. Just to do just one more little example here, you can also have x equals 2 and x equals 5, let's say, and that'll also create two parallel lines. You have vertical lines this time. These don't have slopes. The slopes of these lines are undefined, right? The slopes of these lines are undefined. However, the lines themselves are still parallel. So these are all examples of parallel lines, both algebraically and then visually you can see one example here of parallel lines. Let's take a look at some applications regarding parallel lines. So for our first example here, they want us to find the equation of a line that is parallel to this line and has a y-intercept of 3. Well, if the line that I want to create is parallel to this line, therefore their slopes must be the same. So the slope of the line that I want must also be 2, as this one is 2. And then the y-intercept of my new line, they're telling me is 3, but that's also my b value. So the equation of this line is simply y equals 2x plus 3. Let's take a look at another. So for this example here, they want us to find the equation of a line. It's going to be parallel to this line here. Again, if this line is expressed in standard form and it passes through a specific point. So if I want to find the equation line that's parallel to this line, I need to find the slope of this line. I do not have the slope of this line, but what I can do is I can write this in y equals mx plus b form by isolating for y. And if I isolate for y here, I end up finding that the equation of this line that they're referencing is y equals minus 1 half x plus a quarter. So therefore, since the lines are parallel, the slopes are the same. So the slope of the line that I want is minus a half. So now my equation is y is minus 1 half x plus my b value. Now I want to find my b value, but this is a point on the line, right? They're telling me that the equation that I'm trying to create passes through the point 2, negative 3. Therefore, if I substitute this point into this equation, this equality holds, and it's true. So I can get rid of the y and change it to a minus 3, and I can get rid of the x and change it to a 2, to which I get negative 3 is negative 1 plus b, and you can solve for b, and you get negative 3 plus 1, and you get negative 2. So putting this all together here, we have that the equation of the line is y is minus 1 half x minus 2. All right, let's take a look at another problem. So for the next equation here, same sort of idea. We want to find the equation of a line. Again, it's parallel to this equation, and it passes through a point here. So more practice of a similar style problem, just so you can work through it with me. Maybe pause the video and try it out yourself, check the answer, but same idea. So I need to find the slope of this line. So I'm going to isolate here. This will be negative x plus 2. Therefore, my slope is negative 1. Therefore, I have y equals negative x plus b. And now I can substitute that point in. So get rid of the y, change it to a negative 6. Get rid of the x and change it to a 5. And I get negative 6 equals negative 5 plus b. And I get negative 6 plus 5 is b. And b is minus 1. So putting this together, you get y equals negative x minus 1. All right, let's try another question here. So I want to find the equation of a line that's parallel to this line here and has the same y-intercept as this line. So therefore, same idea. I need to find this slope. So if I isolate for y, I have the slope of the line that I'm creating, is, since it's parallel, will also be minus 1. I need to find this y-intercept here, so I'm going to have to put this also in y equals mx plus b form. And again, if you don't know how to put this in y equals mx plus b form, I'll link a video in the top right-hand corner going through converting from standard form to slope-intercept form. So this becomes 1/5 x minus 4/5. So my equation has the same slope of this equation and has the same y-intercept as this equation. So I'm kind of grabbing characteristics from two different lines and putting it together. So my answer here is going to be negative x minus 4/5. And this is my equation that I want to create. All right, let's take a look at another. So for this question, what we want to do here is find the equation line that's parallel. Right, it's parallel to the, it's parallel to the line y equals to 10. So let's take a look at what the line y equals 10 looks like. So y equals 10 is a flat line here. That's y equals to 10. And I want to create a line that passes through the point 2,7. Well, the point 2,7 perhaps is maybe right about here, let's say. It's 0.27. And I want to create a line parallel. Since the line is parallel, it's also going to be a horizontal line. So since it's going to be a horizontal line, it will also be y equals to what? You grab your y coordinate, right? Because that's the constant term, y equals to 7. No matter what point I choose on this line that I've created here, that I want to make parallel to, you can see this line here, it's the case that I don't know its x-coordinate perhaps because I'm just plotting these randomly, but I know the y-coordinate is 7. Every single one of these, the y-coordinate is 7. That's why you have a constant output of y equals to 7 on this graph. So at any rate here, the equation of a line that's parallel to the line y equals 10 and passing through the point 2,7 is y equals to 7. All right, for this question here, we want to find the equation of a line that passes through the point negative 1 and 4, and this time it's parallel to x equals to negative 2. If you don't know how to do these horizontal and vertical lines, I'll link a lesson in the top right-hand corner here referencing that. But first of all, let's take a look at what the line x equals negative 2 looks like. It's going to look like something like this. And this is the line x equals to negative 2, right? This is because your x value is constant. My x value is not changing, right? If I look at these points here, no matter what I do, my x value is not changing. But I want to create a line that's parallel to this line and cross the point negative 1 and 4. So maybe the point negative 1 and 4 is roughly right here. And this is a line that's parallel. So because it's a line that's parallel, it's going to be an x equals 2 equation. X equals to what? X equals to negative 1. And that creates my equation that is parallel. All right, that concludes today's lesson on parallel lines. Thank you.